Alex here with mixed multiple choice number 36. Question asks, administrators working for a National Sports Association randomly picked 20 Division 1 and 30 Division 3 football programs and ran a two-sample inference procedure to compare the mean GPA of football players in the two divisions. With the null hypothesis of the mean of D1 minus mean of D3 and alternate of mean of D1 is less than the mean of D3, and a p-value of less than 0.05 occurs. Which of the following is a proper conclusion? Well, let's go back to the book, which I've already set up for us. And wrote down all no alternate hypothesis and no hypothesis. Alright, excuse the noise. There we go. Answers 1A through D state that it cannot be concluded. Okay, now here's why all of them are wrong. D states that it cannot be concluded that the observational difference in mean GPA is significant because Division II programs were excluded from the study. However, Division II has nothing to do with it. We can take it out Division II because this is a random test for both Division 1 and Division 3. Okay, for C, it says it cannot be concluded that the observed difference in mean GPA is significant unless students was randomly selected. Well, that's a contradictory because it says right there in the first sentence, administrators working for a National Sports Association randomly picked 20 Division 1 and 30 Division 3 football programs. So the answer cannot be correct. It cannot, and B states it cannot. B states it cannot be concluded that the observed difference in mean GPA is assumed because this was an observational study, not an experiment. Though that statement is true because an observational study is one where you don't impose a treatment, whereas an experiment, you impose the treatment. It's still incorrect because there is a relevance between GPA of football players in the two divisions and how they play football. So the answer is E. I forgot to mention that it is a two-sample inference procedure. So that right there also answers why it cannot be A. Well, not A, but yeah, A. States that the sample does not have to be equal to this. So the answer is E.